welcome to today's lesson. We're going to be talking about parallel lines and perpendicular lines. As always, disclaimer, if you notice a mistake, I apologize in advance. Just let me know where the mistake occurs so that way we can both learn from my mistake. I am human, so mistakes can happen. Also, if you hear any noise in the background, we are recording from home, so the noise in the background is Miss Sylvanas being a happy kitty. Let's go ahead and get started with parallel lines. So parallel lines are lines that never, ever cross in both directions. They just keep on going forever and ever, but they never actually meet or they never cross. And parallel lines look something like this. We saw parallel lines when we were working with parallel lines cut by a transversal. But again, these lines can be in any sort of direction as long as they are the same direction and they never will cross. So one of the key things about parallel lines is that they have the same slope. So parallel lines have the same slope. Now let's talk a little bit more about parallel lines. And so, for example, let's call this line L and line M. So remember, the way we name lines are cursive and lowercase. So for example, if line L has the slope of 3/4, then line M, that's a cursive M, would also have the slope of 3/4. Now, for parallel lines, the intercept, the y-intercept, could be different. If the y-intercept would be exactly the same, we would have the same line on top of each other. So because they are different lines, the only thing that they share is the slope, but the y-intercept is different, okay? These two slopes are an example. These slopes do not correlate or correspond to the example that I have drawn out here. So 3/4 definitely would not work here. This would be a different slope. So let's talk about perpendicular lines. Perpendicular lines for the slope have a negative reciprocal. Now, negative reciprocal is the correct term. I personally don't like negative reciprocal, so I'm going to change it, and I'm going to refer to it as opposite. So opposite reciprocal. So let's talk about what it means to be opposite. So the opposite means that if something is negative, it becomes positive. And if it is positive, it becomes negative. So it goes in both directions. So if we have a slope that is positive, the perpendicular slope would be negative. And if we have a negative slope, the perpendicular slope would be positive. Okay. Now for reciprocal. Now reciprocal, I'm going to move that here. Now reciprocal means, and I'm going to use my own words here, we're going to flip the fraction. Okay, so let's have an example here of a reciprocal. So let's say our original is, 5/8. So let's do an example here. So here's 5, and then here's 8. And so what a reciprocal is you switch the place or you flip the numbers in the fraction. So if 5 was on top, 5 is now going to be on the bottom. Okay, so let's do that again. So let's take the reciprocal of 8/5. Let's take a reciprocal of 5/8. So you switch the position of your numerator and the denominator. So your reciprocal of 5/8 would be 5 would be on the bottom and 8 would be now on top. You flip the fraction. So let's do an example of something that's perpendicular. So if we have an original slope of, let's say, -7 4/15. Let's do original slope. And we want to know the slope of the perpendicular. Now I'm going to introduce a symbol here. Perpendicular is shown like this. And then just so you guys remember, perpendicular meets at a right angle. So those lines are going to cross. And they're going to cross specifically at a right angle. So perpendicular looks like that. That's the symbol for it. Parallel, looks like two lines. Okay, so the slope of the perpendicular line, and that's going to be, again, so let's do the opposite reciprocal. What I'm pointing at here is this section here, opposite reciprocal. So the opposite, let's change color so it's a little bit more noticeable. So what's the opposite of your negative? That is a positive. What is the reciprocal of 7/15? Again, that means you flip it. So 15/7. So your perpendicular slope is positive 15/7. Okay, I want to review already. We've gone through a lot. Okay, parallel lines have the same slope. The y-intercept is different, but the slope is the same. Perpendicular lines have a slope that is opposite and the reciprocal. What that means is if the original slope is negative, it goes to positive. If it is positive, it goes to negative. The reciprocal part means you flip the fraction. That means if you originally have 5/8, then you take the reciprocal and your new fraction or your new fraction is 8/5. For an example, if our original slope is -7/15, then my perpendicular slope would be positive 15/7. All right, let's go ahead. I'm going to separate this. Let's start out with some examples. And then in these examples, we're going to review, okay? So let's do example 1. Use the slope to determine if AB, line AB, and line CD are parallel, perpendicular, or neither. Okay, so what that means is if you have the slope, let me shift this up. If you have slope that's the same, therefore the lines are parallel. If you have slopes that are opposite and a reciprocal, that means you have perpendicular lines. If the slope do not match either of these, then you have a neither case. So let's do the example number 1. Given to us are points. So I have 2, 3, -1, 4, -5, 3, and -4, 6. Okay, review number 1, or review the first thing we're going to review. We need to know what our slope formula is. Remember that slope, or recall that slope is a lowercase m, and it is y2 minus y1 over x2 minus x1. So it's your change in your vertical over your change in your horizontal. So now we have this formula. Let's plug it in. So this is how you're supposed to work on these problems here. The first thing we're going to figure out is the slope of line AB. And then we're going to figure out the slope of line CD. So step number 1, figure out the slope of line AB. And in order to do so, we're going to take the point of A, take the point of B, and use those points to find the slope. So I have 2, 3, and I have -1 and 4. So again, let's label x1. You can barely see that. Let's not use yellow. Let's use a different color. x1, y1, x2, y2. Shift that up so you guys can see. So I'm going to use those 2 points to find the slope of my line. y2 is 4. y1 is, and then make sure you have parentheses here, so that way you know that the negative is outside of what you're plugging into. So I have 4 minus 3 all over x2, which is -1, minus x1, which is 2. So I have 4 minus 3, that's 1. -1 minus 2. If you're not sure what this is, use counters. What do I have? I have 1 negative. What do I have? I have 2 negatives. So what do I have in total? I have a total of 3 negatives, which means my slope is -1/3. And that is the slope of line AB. Okay, now that's step number 1. Now we have to find step number 2, which is the slope of line CD. Very similar, like step 1. Oh, excuse me, that's not right. We want CD. So what is my point for C? It's -5 and 3. What is my point for D? It's -4 and 6. Like we did in step number 1, label x1, y1, x2, y2. Use that to find your slope. y2 minus y1, x2 minus x1. y2 is 6. y1 is 3. x2 is -4. x1 is -5. Again, how am I doing that? I'm using the slope formula. I see 2 negatives. That makes a positive. Remember, only if you can circle it will it end up being a positive. If you cannot circle without crossing out a number, then it doesn't work. You can't change that to a positive. 6 minus 3 is 3. -4 plus 5, that means I have 4 negatives. 1, 2, 3, 4. And I have 5 positives. So 1, 2, 3, 4, 5. These are 0 pairs, 0 pairs, 0, 0, 0. So I'm left with 1 positive, which is here. So that means my slope for line CD is 3. 3 over 1, you can say, or just +3. Okay, now step number 3 is comparing and determining if your slope is parallel, perpendicular, or neither. Okay, so step 3, we're going to look I'm going to look to see if my lines are the same. So let's use the process of elimination. Do we have the same slope? Are my slopes exactly the same? Nothing's different. No. So that means we do not have parallel lines. Let's try not number 2, but let's try the second, perpendicular. So process of elimination, the first one, parallel, that didn't work. So we're crossing that out. Second one is perpendicular. Are my slopes perpendicular? Well, let's see. Do I have the opposite? So do I have a positive that goes to a negative, or do I have a negative that goes to a positive? Yes, I have a negative that goes to a positive. Then, in order to for sure have perpendicular lines, I need my fraction to be reciprocals of each other. So that means I take this fraction and I flip it, and it needs to match this one here. And in fact, it does. So therefore, my answer for number 1, for example, number 1, is that we do in fact have perpendicular. So I can make that, not assumption, but I can make that statement, that final statement saying, hey, because my slopes are opposites and reciprocals, therefore I know for a fact my lines are then perpendicular. All right, let's move on to example number 2. All right, so before we move on to example number 2, I wanted to talk to you about equations of lines. So I believe this was in semester 1 where we talked about the 3 forms of a line. So let's go ahead and just review those. Let me get my phone out of the way. So we were talking about equations of lines. Now there are 3 types of equations that we focused on that I wanted to brush up on. So first one is our absolute favorite, is y equals mx plus b, where we know that m is our slope and b is our y-intercept. The other type of equation we had was standard form. Now, standard form looks like something like this. Ax plus by equals c. Now, for standard form, our a had to be positive, and a, b, and c must be whole numbers, so you can't have fractions. Okay, now the third one, let me actually put this in a bubble so we know. So here's our standard form, here's our slope-intercept form, and then our last one was point-slope form. And again, if you're in my class, you should know this, that mathematicians are what? They are lazy. So we're not very creative at the naming of things. Sometimes we get creative, but most of the time we don't because we're lazy. So for example, point-slope form literally has the point and a slope in the equation. We're not that creative. But I do want to talk about these 3 things. Oh, let me let you know what the point-slope form formula is okay. It is y minus y1 equals m parenthesis x minus x1. And so what I like for this one is keep, change. So you're going to change this slope. We know what this is. Keep, change. So I'm going to write that. And then we're going to keep, change. And so what I mean by keep, change is when we're going to be working with examples, there are only certain things that we're going to change in our formula, and we're going to keep our original y and keep our original x, which are our keep y and x. Okay, so we have three. We have slope intercept. I don't think I wrote the name of it, but this is slope intercept. So we have slope intercept form, standard form, and point slope form. And I think I put a bubble around the wrong thing. We should have a bubble around our equation, and that's okay. Why are we talking about the equations of lines? So when you're looking at perpendicular and slope lines, most of the time what will happen is you're going to be looking at those lines and comparing the slope. Okay. So if you have an equation of a line in slope intercept form, then you already know the slope. You don't have to do anything. If you have an equation in standard form, then you don't automatically know what your slope is, so you have to figure that out. For point slope form, you have the slope here. Sometimes they're going to factor this, sometimes they're going to multiply the slope in, but the slope is always going to be in front of x, just like it is here. So you have the slope. So the most difficult one to work with would be an equation in standard form. So let's talk a little bit about how to deal with an equation in standard form. You have two options in standard form. To find slope, you can solve for y and put in slope intercept form. So you can rearrange things, get y by itself, put it in your slope intercept form, therefore you have slope. That's option number one. Option number two, let me switch this up, is to use the slope formula for standard form. All right, so slope in standard form is going to be your opposite of A over B. So it is your choice if you want to put in terms of y, or if you want to use the formula. I personally like to use the formula just because it saves me lots of time. But this is, let me make sure that's a B. And this is not negative, this is the opposite. Okay, so now we've gone over how to identify slope in your three forms of a line. So let's go ahead and move on to number 2, or example number 2. Let me switch this forward. All right, example number 2 is, let me find a good example here. It's going to ask us to determine whether the equations are, and I'm going to use my symbols here, parallel, perpendicular, or neither. Okay, so the first two are going to be x minus y equals 9 and y equals x plus 4. And I'm going to write out your steps for you. Step number 1, identify the type of equation. What do you have and what does that mean? Still works here. So what do you have? I have an equation in standard form. What do I have? I have an equation y equals. That means I have an equation in, and what I just pointed to is I pointed to here. I have y equals x plus b. I have y equals x plus b. So what do I have? I have slope-intercept. Step number 2 is identify slope. And I'm going to put if you can, without rearranging things. So for example, in this equation, in my slope-intercept form, again, I'm going to shift up. I know that my slope is in front of x. So what number is in front of x? Well, some of you might say there is no number in front of x, and that would be, unfortunately, incorrect. There is a number. Mathematicians are what? They're lazy, so we cut corners, we abbreviate, we make symbols. So we don't like to put things that don't do anything. So for example, there is a times 1 in front of x, but if you multiply anything by 1, that doesn't change anything. So we eliminate it. So what number is in front of x? And that is 1. So I have a slope of 1. If you want, you can put 1 over 1 to make it into a fraction. It's up to you. So identify slope if you can. Step number 3 is rearrange any other equations to find slope. Again, you can skip the rearrangement if you want to use your formula, but in this case, rearranging would be super easy. So I'm going to rewrite my standard form equation, x minus y equals 9. I'm going to rearrange, and by that, I'm going to be solving for y. So how do I get y by itself? I'm going to subtract x, both sides. X goes away. I have negative x plus 9 here. I have a minus y. Again, I have a minus 9, excuse me, minus y. I think I said 9 before. I have a minus y. So I'm going to undo that by multiplying both sides by negative 1. So I have y is equal to, this negative 1 gets multiplied to all terms, distribute. So I have x minus 9. Okay, so now that I have it in slope-intercept form, I'm going to identify the number in front of x. And again, there's nothing here, so that means I have 1 here. So my slope is 1, or if you want it in terms of a fraction, 1 over 1. Step number 4, compare your slopes and determine what lines you have. So again, Are they parallel or perpendicular or neither? So I'm looking at my slopes. Step number 1 is to check if they're exactly the same. If they are, you are done. You have parallel lines. If they are not exactly the same, then you have to check for perpendicular. If they do not meet the requirements of perpendicular lines, then they are neither. In our case, they are exactly the same. So our answer is they are parallel lines. And I am not calling these slopes parallel lines. I am calling the two equations parallel based on the slope. The slope is the same. Therefore, the equations given in example 2 are parallel lines. All right, let's do one more example. Let's do one that's a little bit more difficult. So we are now on example 3. I'm going to say 2x plus 7y is equal to 28. 7x minus 2y is equal to 4. Okay, step number 1. What is step number 1? Let me look at my steps here. Identify the type of equation. I'm not going to write this down, but I'm going to verbally identify it just so we can save some space. What type of equation is this? This is a standard form. What type of equation is this? This is also standard form. So that means I have to rearrange for y, or I can do the equation of a slope. I'm going to choose for this example to do equation of a slope because in my opinion, you don't have to agree with me, in my opinion, it's a lot easier to work with the formula of a slope instead of solving for y when you have big numbers. 28 for me, that's pretty big. Some people might not think that's big. I think 28 is a large number. Okay, so what I'm going to do is I'm going to use the slope formula for finding slope. In standard form. Okay, now it's not the slope formula when given points. It's the slope formula for finding slope in standard form. So what that means is I'm going to do the opposite of A over B. Not negative, opposite. Opposite. Okay, so what I'm going to do is I'm going to write AX plus BY equals C. AX plus BY equals C. And I'm going to label this A and label this B. So for my slope for A, I have 2. My B value is 7. Now make sure you take the sign with it. Make sure you take the sign with it. So my slope for A is the opposite of 2 over 7. Now let's do the slope of B. My A value is 7. My B value, again, take the sign, is negative 2. And again, what am I doing with it? I'm taking the opposite of it. Simplify your fractions if you can. This is negative 2 7s. 7 and 2, you can't simplify that, but I know I have 2 negatives. Negative times a negative is a positive, so I have a positive 7 halves. After you find your slope, compare. Are they exactly the same? No, so that means they are not parallel. Are they opposites of each other? Yes. Do we have reciprocals? Are our fractions flipped? So 7 was on top, 7 is on the bottom, 2 is on the bottom, 2 is on top. Yes, so yes on opposite, yes on reciprocal. That means the two lines that were given are perpendicular. Okay, let's do one last example using our point slope formula. And I take that back. I'm going to go ahead and wrap up this video here. In the next video, I'm going to talk about how to write parallel and perpendicular lines using the point slope formula. And let me back up a little bit. We're going to use the point slope formula and a point to write the equation of slope, to write the equation of perpendicular and parallel lines. Woo, this ending for me has been fantastic. I am being sarcastic here. As always, if you catch a mistake, please let me know where the mistake occurred so that way we both can learn from my mistakes. I do apologize in advance for that wonderful ending that I just did. Thank you again so much for watching, and I'll see you in our next video.